Hi, this lesson is about division of polynomials. So we'll be dividing two different scenarios. First, we'll be dividing a polynomial by a monomial, or a single term, and then we'll be dividing a polynomial by a binomial. And for the second type of problems, we will be using long division. All right, so let's start with the first type, dividing a polynomial by a monomial. So here's our first example. I have 2x cubed minus 5x squared plus 7x, and this bar here means divided by x. So the top part is called the dividend, and the bottom part is called the divisor, and my answer is called the quotient. Okay, so when you have a monomial as a divisor, all you have to do is divide each individual term in the dividend, or the numerator, by the denominator. So that's what you see on this line. I'm going to divide 2x cubed by x, 5x squared by x, and 7x by x. So you have to use the rule that we learned in the previous section, which is to subtract your exponents when you have the same base. So that's what we get in our final answer. When you subtract x cubed and x, that means you're subtracting 3 minus 1, because those are the exponents. So you get 2x squared as my first term, then 5x as my second term, and 7 as my last term, because the x's will cancel in 7x divided by x. All right, so let's move on to number 2. So I have 4a squared b minus 8ab plus 7ab squared divided by 2ab. So again, each individual term in the numerator gets divided by 2ab. So you simplify and combine your exponents as much as possible. In the first term, the b's cancel, so you just get 2a. In the second term, both a and b cancel, so your second term is just minus 4. And in the last term, the a's cancel, and b squared over b leaves you with 7 halves b. So that's your final answer. Okay, let's move on to number 3. It's the last example of a polynomial divided by a monomial. This time my polynomial has 4 terms in the numerator, and my monomial, or my divisor, is 3xy. So again, each individual term gets divided by 3xy. And when you simplify, here the 3's will cancel. X cubed over x gives you x squared. Y squared over y gives you y. Now we move on to the second term. 6 divided by 3, well, 3 goes into 6 twice, so you have 2. X squared divided by x is just x, and the y's will cancel. Third term, 9 divided by 3, well, 3 goes into 9 3 times. The x's cancel, and y squared divided by y is just y, so we have 3y. And then the last term, 12 divided by 3, 3 goes into 12 4 times. The x and the y in the denominator do not simplify or cancel with anything, so your last term is 4 over xy. All right, so let's move on to using long division to divide a polynomial by a binomial. So remember the vocabulary. The expression that's being divided is called the dividend. The expression that's doing the dividing is called the divisor, and your result is the quotient. It is possible to have a remainder as well, so we'll see examples of expressions with a remainder and without a remainder. All right, so here we want to divide x squared plus 5x minus 6 divided by x minus 1. Remember, the first expression is your dividend. The second one, the binomial, is your divisor. So when you set it up in terms of a long division problem, the divisor goes on the outside and the dividend goes on the inside of this bar. For some of our international students, it may be written in the opposite direction, where the divisor, I believe it's written like this for international students, divisor goes on the inside and the dividend goes on the outside. So if you prefer that, that's fine, but I will be doing all of our long division the American way. Okay, so when you're doing long division, what you're doing is you're looking at the first term in the divisor and the first term in the dividend and the first term in the divisor, and you are actually dividing them. So I'm going to put the work here on the side. If I do x squared divided by x, my result is x. That's what you write down in your quotient. Your quotient or your answer goes on top of the bar. Then you take that value of x, and you multiply it across your divisor. My divisor, remember, is the expression on the outside, x minus 1. That result is what you see here on this line. If you were to distribute it, you would get x squared minus 6. But to move on to the next line, you have to subtract the x squared minus x from the dividend above. So when you subtract, so that's why this minus sign is here, that means you have to distribute that minus sign across both terms, which means when you distribute, the first one turns to a negative, the second one turns to a positive. So when you combine the first line and the second line, you get what you see below right here. This is 6x, the x squareds will cancel, and you get 5x and x is 6x, and then you bring down the next term. Then you repeat the process. You take the first term and divide by the first term. So that's what you're going to see here. 6x divided by x gives you 6. And that's what you write down right here. If it's positive, you put a plus 6. And if it was a negative 6, you would put minus. Then you do the same step you did above. You take that 6 and you distribute it across the divisor. And that's what you see right here. 6x minus 6 is what you get when you distribute. Then again, the line above minus the line below, when you subtract, your signs change. This turns to a negative, this one turns to a positive. That means everything cancels and your remainder is 0. So your answer, or your quotient, is just x plus 6. And just like long division with just numbers, you can check, which is what I did here. You can take your divisor and multiply it by your quotient or your answer, and that result should give you the original dividend, which it does. So if you were to FOIL this out, so you have to expand this by FOILing first, outer, inner, last, and you would get x squared plus 5x minus 6. So it checks out. All right, let's move on. Here I have b squared minus 9b minus 9 divided by b minus 6. So again, the b squared minus 9b minus 9 goes inside of the division bar, and the b minus 6 goes on the outside. So remember, the steps are take the first term on the inside, divided by the first term in the divisor, and divide them, and you get b. That's what you write down right here. Then you take that b and you multiply it across your divisor, which is what you see right here. That's b squared minus 6b. Then you need to subtract. So when you subtract, you're distributing that minus sign across. So this one turns negative and that one turns positive. So when you actually do the subtraction, the b squareds will cancel, and negative 9b plus 6b gives me negative 3b, which is what you see on this line. And you also need to bring down the next term, so the minus 9. Make sure you bring down not just the number, but the sign in front of it as well. Then we repeat the process of taking the first term here, negative 3b, and divide it by the first term in the divisor. That gives me negative 3. So that's what you write down right here, minus 3. Then you take the negative 3 and you multiply it across your divisor, and you get this result, negative 3b plus 18. Again, remember, because you are subtracting, your signs will change. And so this one turns to a plus and that one turns to a minus. So the 3b's will cancel, and negative 9 minus 18 me a remainder of negative 27. So I know this is a remainder because I don't have any other terms to bring down here, right? I'm done. There's nothing else to carry down. So negative 27 is considered to be the remainder of the problem. So the way you express that is you would take your quotient, b minus 3, minus, and then you put the remainder over your divisor. So it's minus 27 over b minus 6. Sometimes your web-assigned homework might not like it in this order. So if you put it in, you're confident you did it right, you can try entering your answer like this, where the variable terms go first. So in other words, write b, then your remainder 20 minus 27 over b minus 6, and then the constant at the end. They both mean the same thing, but again, just in case your homework system gives you some trouble, try putting it in this second way right here. And just like I checked my first example, you can check this example as well, except you'll have an additional step. First, take your divisor and multiply it by your quotient. You FOIL that and you get this, b squared minus 9b plus 18. But then you have to add in your remainder. Because my remainder was negative, you actually are subtracting it. So when you subtract 18 minus 27, you get b squared minus 9b minus 9, which is actually the dividend that you started with. So that's how you know that it checks out. Okay, so let's move on. This one is a little bit different in two ways. First, my dividend has 4 terms in it. And secondly, it is written in a non-typical order. So remember, we always want the highest degree first, and then you want to go backwards from there, second highest degree, third highest degree, and eventually end with the constant. So I did 2 things here. I set up my long division problem, but I also reordered these terms so that x cubed goes first, minus 10x squared, plus 15x minus 5. If they're not in the appropriate order, you will not be able to do this with long division. So pay attention to that. Then you repeat the process. I'm just going to talk this one through instead of writing it out. Take x cubed divided by x, you get x squared. Then you take the x squared and you multiply it across x minus 1, or your divisor, and that gives you x cubed minus x squared. And then you need to subtract that. And when you subtract that, remember, your signs change. This one becomes a negative, that one becomes a positive. So the x cubes cancel, and you get negative 10x squared plus 1x squared, which gives me negative 9x squared, and then you bring down the 15x. Then you repeat the process. Take the first term here, the first term here. Negative 9x squared divided by x gives me negative 9x, which is what you see here. Then multiply the negative 9x across this divisor, which gives me what you see here, negative 9x squared plus 9x. That expression, you have to subtract it from the expression above, which means the signs will change. So I'll get a plus here and a minus here. So the 9x squareds will cancel. 15x minus 9x is 6x. And then you, again, bring down the last term. And this will be the last time we have to do the process because there are no more terms to bring down. Then you take the first term here, divide them. That gives you a positive 6, which is what you write in your quotient. Then distribute the 6 across x minus 1. You get what you see here, 6x minus 6. Subtract, signs will change. This is negative, this one's positive. and you get a remainder of 1. So the way you write that is x squared minus 9x plus 6, that's your quotient, and then your remainder this time is positive, so you put plus 1 over x minus 1, and so that's the answer that you get. And again, if you have any trouble with the format in WebAssign, try putting it in as follows with your variables all together and your constant at the end. They both mean the same thing. It's just a formatting issue. Okay, let's go on. Here's number 4. So the initial problem is presented in a slightly different way. So again, I'm using this bar as my division symbol. But again, it's still a long division problem because my denominator is a binomial. So I write it here as a long division problem. But I also have another issue going on because notice that my degree here is 3, and then I go to z, and then I have a constant. So I'm missing a z squared term. And with long division, in order for things to line up properly and stay organized, you need every term represented. So we play a little trick here, and we force a z squared term to exist by just putting a 0 in front of it. So anything that's missing, you would just put a 0 in front of the missing term. So I again have 4 terms in my polynomial. I have to divide z cubed plus 0z squared minus 3z plus 4 by z minus 3. All right, then I repeat the process. I take the first term on the inside, divide it by the first term on the outside. That gives me z squared. Then take z squared and distribute it across z minus 3. You get z cubed minus 3z squared. So that's exactly why you want that 0z squared term to exist, because otherwise you would have unlike terms lining up. You don't want negative 3z squared underneath this term because you would not be able to combine like terms. Okay, so then you subtract, and again, signs change, turns to negative, that one's positive. You do that subtraction, z cubes cancel, so you get 3z squared, and then you bring down the minus 3z. Repeat the process, take the 3z squared divided by z, that gives me just a positive 3z, which is what you see here. Take the 3z, distribute it across the divisor, you get 3z squared minus 9z. Subtract, this one turns to minus, that one turns to a positive. These cancel, and you get 6z, and then you want to bring down the last term, which is, that means you only have to do this division one more time. So take the first term, 6z divided by z, and you get 6. That's what you write down here. Everything's positive. And then take the 6, distribute it across z minus 3. You get 6z minus 18. And when you subtract, your signs erased the wrong thing. Your signs will change. So this becomes a minus. This one becomes plus. So you end up with a remainder of 22. So the way you express that answer is here on the box, in the box. So I have my quotient, z squared plus 3z plus 6, and then my remainder is positive, so you write plus 22 over your divisor. And another format would again be z squared plus 3z plus 22 over z minus 3, and then the plus 6 at the end. Okay, so that's it for this lesson. Try giving the homework a try. Good luck.